Hi, good day. This is Mr. Max. I am doing a quick question on vectors, especially where you have the diagrams. So I'm just going to delve directly into it. It says the diagram shows triangle OPT, and then in triangle OT, in the diagram OT is equal to T. So that suggests that from here all the way up to there, that is where the T is, and obviously OP down here is represented by vector P, as you can see. All right, so let me just then go ahead and fill in the missing information. So they are saying that OK is 2, OK to KT is 2 to 1. That simply means that whatever this distance OK is over here, that will be 2 out of 3 parts of T, and this one KT will be 1 out of 3 parts. All right, so I'm just going to take away the T there so you can understand. Okay, and then they say that TL, so again TL is 2 to 1 of LP, so this is also 2 out of the 3 parts, and this one here LP is 1 out of the 3 parts. Okay, now that we have our information written down, so let me just write that 1 over 3 inside here, because I might be using that space a little bit later. Okay, now they say find in terms of T and P in its simplest form. Remember, when when you are using a pen, you are not using you are not bolding, so you're going to underline those vectors represented by those letters there. So they want us to find PL, and the way you find PL, uh, think of it as a direction that you take. So you're going to PL. It's like going along OP, then going OT, but and then also going this distance of TP or PT, because I'm going down upwards. So what I'm going to do first, I'm going to say what is the distance? What is the distance of PT? And I'll write it here. PT, looking at my PT over here, that is going to be equal to PO plus OT. Okay, so I can play around with that using the vectors. I know that PO goes against that P, so I'm going to say minus P plus, of course, you're going to put a line underneath it, and OT is represented nothing but by T. But we're now looking for the distance PL. And PL, you're going to find PL by simply saying that is a third of PT, which is a third of what I just got, which was minus P plus T. Okay, you can also leave it like that, or you can just as well distribute over. You can also put a T in front of the P when you want the like terms or positive terms. All right, so another student could say, okay, well, this is nothing but a third of T minus a third of P. Still the same thing. KL, well, here's the catch of KL. Now, when you are going from KL, and I'm going to use my diagram over here, so KL is nothing but going from KT plus TL. Very important that you have a concept there. KL, that is going from KL, so that's the same as going a third plus TL. Okay, or you can say KL going from K to L is the same as going KO, which is along down here, plus OP, which is this direction here, plus PL. The reason why I'm choosing this one is because I somehow know already from my previous answer what PL is. So I'm just going to, and I want to keep that diagram in the rear so that you can see. So let's just have a look and see if I have to write it over here. So this is nothing but KO plus OP plus PL. So looking at my diagram, what is KL? Now, let's go back there. KL is a third, or KO, rather. KO, that's against the T, minus 2/3 of T. So that will be minus, I'm going to write it over here. So that is minus 2/3 of T. And OP, the distance from O all the way to P is nothing but P. And PL, I got it from my answer here, which is a third of T minus a third of P. Okay, so I'm going to clean that up so that I can find what my answer is, and go ahead and use your calculator if you want to. So first of all, when you look at your values of P, this is 1, take away a third, and 1 take away a third, that is 2/3 of P. And they have, that takes care of the P, for example, and this 1 over 3 T, or 1 over 3 minus 2 over 3. Okay, so we are now here at 1 minus 2. 1 minus 2, well, that gives you negative 1 over 3t. Again, just use a calculator. It's like treat these things like coefficients, and then you sort of add them and so on. So this coefficient going along with this coefficient, obviously that gives me this particular value over here. And then the same concept applies with this coefficient of 1, which is over here, minus this coefficient, that gives me that 2 over 3. Of course, putting those in terms of P and T. Now, let's look at part B. They say that Km is equal to whatever you have there. KL is an extended, or is extended to the point M. And now they say you must show that M lies on OP. So let me just go back to my diagram so that I can just bring in what is it that that they are referring to here. So I'm going to take away this work here, and I hope that you have recorded it when you were doing the question. The diagram is not drawn to scale, but I'm going to do my best just to highlight what the issue is. So suppose that, and let's suppose that. Okay, so that's just a rough drawing. So my point M is over here, and they're saying that KM, that distance over there, all right, they gave me that distance over there, so I'm just going to write my KM over here. Okay, it is information given, KM, and if you don't know, just let's scroll down. So I'm going to rewrite this whole stuff over here. So KM is nothing but minus 2/3, okay, minus 2/3 of T plus 4 over 3 of P. Let's just go make sure that we have the correct values there. Minus 2/3 of T plus 4 over 3P. Okay, so that's the distance K to M. So what do you think will be the distance O to M? And I'm going to rewrite this maybe using a different color so you can see. So I'm going to use my diagram. So if I want to find OM, O to M, and because I don't know what P to M is, so O all the way to M, I'm going to go OK. Okay, that is OK plus, of course, that KM. All right, and this is very important. And also you realize that OK is that 2/3 of T, all right, plus whatever I have over there. And I'm going to use that answer to see what that answer is. And I'm going to use that answer and compare it to the distance OP. And if a point lies on the same line that is extended, then one has to be a multiple of the other. Okay, so if this is 1P, then the distance from O to P should be something more than 1P. So when that is the case, if one is a multiple of the other, that implies that they are lying on the same extended line. All right, so we're going to use that, and we're going to say OM. So again, I'm going to come down here, and I'm going to say, okay, OM. Let's just go back to what I have written. That's OK plus KM. Okay, so that is OK plus Km. And OK, if you go back to the diagram, you will see that OK goes along this here, so that's 2/3 of T. So that's nothing but 2/3 of t plus, now I'm going to obviously just maybe change this color over here, and my km is nothing but minus 2/3 of t plus 4/3 of p. Of course, this information is given to me here. If I was to remove the brackets, you'll realize that I'm going to be left with 4/3p. And that is all I need to show. What do I know? I know that from my diagram, I know that OP, from my diagram, OP is nothing but P. And if that is the case, that this distance over here from OP is represented by P, and OM is 4/3P, all right? So that is P, and OM is 4/3P, then you can say, then you can conclude that OM is a multiple. And I'm just going to write that down somewhere here. Of course, I expect you to do quite a better job than me when you are writing and recording this down. So it's a show question. You need to show quite a lot of information. So I'm going to say OM is a multiple of OP. Okay, therefore M lies on OP extended. All right, so that should definitely give you enough to sort of score marks in that paper. All right, so just recap again on vectors, and then you will probably see that the questions on these type of problems are not really that complicated. Okay, it's just a matter of thinking of these things as direction, and once you look at it as a direction, then definitely it will be much easier. All right, also when we are saying in the exam you may use a pencil in your diagram, these are the type of things that we are referring to. Of course, it makes your work very easy working straight from the diagram.